Hi everyone, my name is Preeti. Pursuing my education in Sri Venkateshwara College of Engineering, Bangalore. This is a USN 1BE 22EC082. The subject is microcontroller. So my topic is concept of the stack and its last in a first out principle in the context of the 8051. So now let us learn about introduction to stack in a 8051. So the stack is a last in a first out data structure in a 8051 microcontroller. It is used to store data temporarily during the subroutine calls and interprets. The stack pointer register keep track of the current top of the stack. We have two stack, one push and pop, last in and first out. In the both of the last in and first out, the pointer register keep tracking of the current top of the stack in a 8051. So next let us learn about stock operations in a 8051. In a stock operation, push operation is used to store data onto the stock in a 8051. Pop operations returns data from the top of the stack. Stack is a 8051 grows downwards in a memory in a 8051. So in stock operations we have four push operations: push A, push B, and push D. And we have another one empty stacks in a 8051. So now next let us learn stack pointer and a stack size. In a pointer in the 8051 in a 8 bit we have a register of 8 bit. In a stack size in a 8051 is limited by the memory available for the stack. Stack overflows across when the stack pointer exceeds the stack size. This is the log diagram of pointer and the size of the stack in a 8051. So next in microcontroller, the stack usage in a subroutines, which we before calling the subroutines, the calling routines pushes the necessary data onto the stack. Upon returning from the subroutine, the calling pops of the data back from the stack. Subroutine parameters and return addresses are commonly stored on the stack. This is a diagram of the usage of subroutines. Nexting subroutines. The program technical of a subroutines call another subroutine. This is process is limited only by the number of available stack locations. This is a subroutine 1 and this is a subroutine 2. We have a different numbers to call the addressing of the stock, which stores in a stock of the commonly addressed to use usage of subroutines in a microcontroller, which program the techniques of the different types of the subroutines calls pushes or pop of the data back from the stack. Upon the returning from the subroutines, the call routines pops of the data will be ensuring the microcontroller which usage in the subroutines which can. So next let us learn about stack usage in interpreter service routines, that is ISRs. So when interpreter occurs 8051 automatically pushes the program counter onto the stack. ISR pushes additionally data onto the stack for the processing. Upon exiting the ISR to the 8051 pops to PC bags from the stack. This is a interpreter servicing routine in a 8086. This is a program and this is a interpreter and next physical address of the next instructions. We have for different types of label which pushes flags clear if and tf, pushes cf and pushes if isr from ivt. Interpreter programs isr is a pop and push flags of the across the programs counter, which additionally data stores on the stack and processing the day by day and exiting the isr in a 8051. So next we will learn advantage of using stack in a 8051. Which are the advantages in a stack means a stack allows the efficient memories management during subroutine calls and simplifies the process of saving and restoring the context and during interrupts. Facilitates retains and resumes functions calls. This is a log diagram of stock which we have not accessibles and dynamic data, statistic data, literals and instructions. These are the different types of usage stocks in 8051, which allows the efficient memories and day by day management during subroutines call and addressing the data, saving and restoring the content which during the interprets, which functions calls the addressing different types of addressing data and memories which stores a stock allows efficiency in 8051. So next, stock limitations in a 8051. So let us see limited stock size restricts and depth of the subroutines call and nested interprets. In a stock, in a microcontroller, we have manipulations require carefully attentions to avoid a stock overflow or underflow. Insufficient stock usage can lead to memory wastage. We have a 3, back 2 and back 1. This is a limitations which we have used in a 8051, which the depth of the subroutines calls underflow and avoid the manipulations which requires the carefully attentions to usage of leads and memories wastage. So next we'll learn stack implementation in 8051 assembly language. Push and pop infrastructures are used to manipulate the stack in a 8051 assembly language. SP is decremented during push operations and incremented during pop operations. We have two different types of operations, push and pop. Proper stack management is crucially for the correct functionals of the programs. This is a stock in a 8051 push and pop coding which implement the assembly language to the used manipulate of the stock of 8051. So we will learn stock details about assembly language. So next let us see about example of stack usage of 8051. So in a consider of scenario which multiple subroutines calls are made in a program usage in a 8051. Each subroutine pushes its local variables onto the stack. The variables are popped back when the subroutines retains, ensuring the data integrates of the stack usage. So scenario which multiple subroutines calls the addressing data and the local variables on it the stacks. This is the coding of the usage in a 8051 which calls of the subroutine implements. So now let us see conclusion of the stack. We have learned a whole detail about the stacks which based on the LIFO principle plays on a role in a memory management in a 8051. Understanding a stack operations is essentially for efficient programs executions in a 8051 microcontroller. Proper stack usage ensuring the data integrated and prevents memory related issues, which we have seen the whole detail about the concept of the stack memory, which we have different types of physics, chemistry, maths in a stack pointer and pop push. We have learn about the details about operations which the stock management data operations to essentially executions in a coding, which it will help for the codings and executions of the 8051 microcontroller, which we have the different types of usage in a assembly language. We have learned about the stock and this is a microcontrollers of the management which we have seen only in a 8051. So this is my topic. So thank you.